Okay, we are on lesson 2.2. This is page 38. And we're going to apply the LCM. It says you can use the LCM of two whole numbers to solve problems. Let's go ahead and check out example 1. Example 1 reads, a store is holding a promotion. Every third customer receives a free keychain, and every fourth customer receives a free magnet. Which customer will be the first to receive both a keychain and a magnet? Step number 1 says list the multiples of 3 and 4. And then it says then circle the common multiples. I'm going to, just for a minute, I'm going to cover up the textbook writing. And we're going to pretend that we didn't have this in front of us here. And step number 1 says list the multiples of 3 and 4. Now I'm going to go ahead and do the factors first. The factors of 3 are 1 and 3. The factors of 4 are 1 and 2 and 4. And I did that on wrong. These are called factors. That's not right. But that's what we've been working on for the past few days. So I want to point out to you that what we're moving into now is multiples. It's a different idea. But the problems look the same. So I'm going to go ahead now and cover that up. And let's talk about how they look the same, but they're different. Multiples, and this is really important that you catch. Multiples are when you take these numbers right here and multiply by 1 and 2 and 3 and 4 and 5 and 6 and 7. And basically you can do that indefinitely. The multiples of 3 are 3 times 1 is 3. And 3 times 2 is 6. And 3 times 3 is 9. And 3 times 4 is 12. 3 times 5 is 15. And you can keep going forever, but sometimes you just do a few and then stop. Now let's do the multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. And you can keep going forever. So then what we do is we read step 2. It says find the LCM. LCM stands for least common multiple of 3 and 4. Well, the common multiples of 3 and 4 are 3 and 4 are not in each list. 6 and 8 are not in each list. 9's not in both lists. But look at 12. 12's in both lists. So the C part of LCM stands for common, and they're both multiples because we got those numbers by multiplying. And the L stands for least, so the LCM is 12. The least common multiple of 3 and 4 is 12. And then we rewrite our sentence at the end. The first customer to get both a keychain and a magnet is the 12th customer. So while this looks like the factor problems we've been working on, the main difference is when you get ready to solve, you're not listing factors, you're listing multiples. I want you to try the your turn. And so go ahead and hit pause, try the your turn, and then hit play when you're ready to check your answer. Alright, the directions for number 2, your turn. Say find the LCM of 4 and 9 by listing the multiples. So the first thing you're supposed to do is list the multiples of 4. And I guess I made a whiteboard here and I didn't need to do that. I'm just going to work right on here. So the multiples of 4 include 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And I'm going to stop right there just for a minute and I'm going to go do some multiples of 9. And as I'm going, I'm just going to keep the multiples of 4 in my head. I mean, I've got them right in front of me, but I'm going to check to see if I have a common multiple. Multiples of 9 include 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. I'm going to stop there. I'm going to go do some more 4s because I don't have any common multiples yet. So I left off on 4 times 5. I need to do 4 times 6. That's 24. 4 times 7. That's 28. 4 times 9. No, I'm at 4 times 8, that's 32. And 4 times 9, that's 36. And I notice here that I have a 36 in each list. The least common multiple of 4 and 9 is 36. Alright. Let's go ahead and check out the guided practice. Guided practice is just 2 questions here. We're going to do them on this video because we have plenty of time. So let's go ahead and check this out. Number 1. Every 9th visit to a restaurant, you receive a free beverage. After every 12th visit, you receive a free appetizer. If you visit the restaurant 100 times, on which visits will you receive a free beverage and free appetizer? At which visit will you first receive a free beverage and a free appetizer? And I think this would be a really good one to have, that hundreds chart that we used in the Ned biathlon problem. So I'm going to scroll back up a couple pages, and I'm going to go ahead and grab a picture of that. And I realize that it's not quite fair. You don't have an electronic book for you to do the same thing here. But you could go look at it. So I'm going to shrink that down. I'm going to scroll my page back to where I want to be, and I'm going to use this when I answer my question. So I've got a little chart here. And the first question says, well, the first thing you're supposed to do is go through and figure out when you get a free beverage. You get a free beverage every 9th visit. So I'm going to go ahead and do my multiples of 9, and you can use the multiplication chart here. 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 54, 9 times 7 is 63, 9 times 8 is 72, 9 times 9 is 81, and 9 times 10 is 90, 9 times 11 is 99. I could keep going, but it does say you're going to visit the restaurant 100 times. So I have done this one. Those are my beverages. Every time you get, every 9 visits, you get a free beverage. So now I'm going to switch over to doing the same thing as I did last time, except for I'll circle. I'm going to circle every 12th visit because I get a free appetizer there. So the first time that you get a free appetizer is on visit number 12. And then the next time you get a free appetizer is on visit 24. And mathematically what I'm doing now is I'm listing the multiples of 12. 12 times 1 is 12. 12 times 2 is 24, 12 times 3 is 36. Now that's shaded and circled, so I suspect that's going to be part of my answer later. 12 times 4 is 48, 12 times 5 is 60, 12 times 6 is 72. That's double shaded. 12 times 6. 12 times 7 is 84. 12 times 8 is 96. 12 times 9 is 108, so that's off my chart. So I have 2 answers here that are double circled. It's 36 and it's 72. Those are double circled. So let's go reread the question and make sure you understand how these double circles apply. It says, if you visit the restaurant 100 times, on which visits, plural, will you receive a free beverage and a free appetizer? Well, if it's circled and shaded, that means that it's going to be on the 36th and 72nd visits. That's the answer to the first question. Twice you get a free appetizer and a free beverage. The second question says, at which visit, plural, I mean singular, at which visit, plural, singular, will you first receive a free beverage and a free appetizer? Well, which visit would come first? There's 2 options. It's either going to be the 36th or the 72nd visit. Clearly the 36th visit comes first. So the 36th visit is when you get, is the first time you get both a free beverage and a free appetizer. Alright, question number 2 says, what steps can you take to find the LCM of 2 numbers? I think the first step is to list the multiples. After you list all the multiples, you carefully examine. And I'm going to say carefully examine both multiple lists. And the last step is to select the lowest number, or the least. I'm going to say least because that's consistent with our terminology. Select the least number on both lists. Okay, good job. You are done with page 38.